Want to hear a cool story? Yesterday, I gave my wife a bottle of tonic water. It swept her right off her feet. All right, how's it going, Alex Bros? Thanks for muscling through those first two videos. We're on to our third. Okay, there's one more after this. Hopefully, this one will be brief because we're just going to introduce the discriminant of the quadratic formula. Okay, Um, and what the discriminant will do for us is it will kind of help us predict, what kinds of solutions we'll get to a quadratic equation. Not necessarily what they are, but what kind they'll be. All right, so with the introduction of the imaginary unit and complex numbers, it's well within the realm of possibility that our solutions will either be real or complex, containing the imaginary unit. All right. So to give a little point of reference here, I'd like to go ahead and jot down the quadratic formula again. It goes negative b plus or minus the square root of b squared minus 4ac, and all of that is on top of the product 2a. The discriminant is actually this part that's inside the square root of the quadratic formula. So what it says here, discriminant box, let's go ahead and insert the expression b squared minus 4ac. Notice that there's no square root around it, okay? And that's what we mean when we're referring to the discriminant. Okay, so I got to take you through a case-by-case situation with regard to predicting what the textbook likes to say, the character of the solutions of a quadratic equation. Basically, we'll be predicting what kinds of numbers we'll be getting as answers. All right, so let me go through this little chart here. There are three cases. The first case is if the discriminant, after plugging in the values of a, b, and c, is positive or greater than 0, then we will know ahead of time that the equation is going to have two unequal real solutions. Okay, so for example, you might have something like x equals, crappy x there, x equals -1, and x equals +2. Okay, so that's what we consider two unequal real solutions. They're both real numbers, and they're obviously not equal to each other. It's possible that after you plug in a, b, and c into the discriminant, that it winds up turning into 0, in which case we would say that the equation would have a repeated real solution, aka a double root. All right, so basically what that means, if you went through and solved the quadratic equation, you would find as your answers for x, they'd be duplicates. So you might get x equals -1 and x equals -1. All right, so that would be what we mean by repeated real solution, aka a double root. All right, the last case is if the discriminant is negative. If you think about it, if the discriminant is negative, then we will be taking the square root of a negative, thereby producing a complex number. All right, so for that reason, if the discriminant is less than 0, the equation is going to have two complex solutions that are not real, meaning they'll have i's, some weird Doctor Who stuff. But as an added bonus, the solutions are going to be conjugates of each other. All right, so for example, if we had a quadratic equation with the discriminant less than 0, we could possibly have answers such as this: x equals -2 plus 5i, or we'd have x equals -2 minus 5i. All right, so it's always going to happen that if the discriminant is less than 0, you'll have these complex numbers with the i's. But as kind of like an added bonus, those two solutions will be strongly related to each other in the sense that they're always going to be conjugates. Conjugate any more neat than that, right? All right, so that's it for this video. Our last one is on deck, where we will be putting the discriminant to use to predict the nature or character of the solutions. And I'll also show you how you can kind of gather the type of solutions you'll get based on their graphs. So I'll see you shortly. Thanks for watching.